Next speaker is Dr. Arakawa. I'd like to introduce Dr. Arakawa. Dr. Arakawa is a professor at Kyushu University. He worked at Keio University, Nara Institute of Science and Technology, and then now at the Graduate School of Information Science and Electrical Engineering, Kyushu University. This talk introduces the latest research on human activity recognition and behavior change support systems using ICT technologies. So Dr. Arakawa, please go ahead.
This mic. Can I use the wires one? Okay. Thank you for the kind introduction, Chairman. So I'm Yutaka Arakawa, so from Kyushu University. Today I'd like to talk about the ICT-based behavior change support system. So that topic is a bit far from this community, I think, but until 30, I was study in this community, but after 31, I tried to remove the research topic and I moved to try to the Kawahara sensei's part. And nowadays I do this such a work. So today I become a bit nervous because my supervisor Yamanaka sensei is sitting here. So thank you very much for attending. So please enjoy my talk. So the first of all, so I want to introduce my laboratories. So my laboratory is Applied Human Information Systems in Kyushu University. I established my laboratory 2019. So they just spent 3.5 years now. And but we have already 6 faculty members and around 50 students, including the 13 PhD students. And we deal with many kinds of research topics related to human information systems. And I'm in the center. I organize everything, but I hired many assistant professor, associate professor, and someone focused on measuring the human activity, and someone focused on data analysis, and someone focused on how to change human behaviors. So we do everything for every kind of applications. So it's kind of a small company, and today I only focus on this right bottom part. So how to change the human behavior. But the basic technique is, there are many basic techniques, but I couldn't introduce today. So if you have interest, please access to my laboratory's homepage. So anyway, so I pick up the several topics in my laboratories. So the topic is mainly focused on the physical and the mental state recognition of human. And we observed our body movement, so eye movement, so some biological sensing data. We try to figure out how the human feel, how the human considers. And this can apply for the learning support system. Nowadays, the human join the lecture through the online. We deploy some sensing system for Teams or Zoom. We monitor the student face. I didn't introduce today, but all the meeting in our laboratory is recorded and all the face is analyzed. So even for this conference, I want to sense all the attendees who are concentrated on my talk, who feel sleepy or something, who have much attracted, everything becomes a topic. And also we have the smart home in the university. I built the 2 houses in Kyushu University. Also in the previous university in ICE, I have also 1 additional house. So we can deploy many sensors in the actual home, and we actually live inside the home and monitor the human behavior. So in the home. Also we deploy many sensors in the city. Even in the Fukuoka city area, we also deploy 13 AI camera in the city central. So today I will introduce, so the bus around the campus. We have the company Showa bus using the 50 bus. We have already deployed the sensor, installed the sensor to all the bus come to the campus and monitor the city people movement into cities. And the final one is the behavior change support system. So I will talk. So if we do such a research, AI and sensor can recognize our behavior accurately. So we start considering what happened in the future. Someone said the singularity. So the AI exceed human or something. But I start considering 10 years ago, and now I introduce some research result in this talk. And our fundamental target is the human activity recognition. I and also Kawahara sensei work in this field, so ubiquitous computing field. So we, as I said, our target is all our life, from the morning to the night, even the sleeping time, also from the baby to elderly people. So every point we want to recognize what human do. And of course, no sensor that can sense all human life. So this is because we need to choose some sensor suitable for the topics. So this is because we have the 20 or 30 topics, and we choose the 20 or 30 sensors. And also sometimes we develop a new sensors for sensing the human behavior. And we apply a machine learning technique or deep learning technique for collecting the data. And finally, we try to figure out the human behavior. That is fundamental my research topics. And these topics is drastically changed 10 years ago. So I changed my topics. This is because, and that is a smartphone. The iPhone started selling in Japan 2008 or something. And after that, we can easily use such a devices. So nowadays we have many wearables, the IoT devices. So maybe most of people wear some smartwatch and bring the smartphone. And the smartphone itself has a strong connectivity, always connected to the internet. That is a strong point, but also, so the important point is the various sensor is included, embedded in the smartphone. So I didn't show all the sensor in the smartphone, but the famous one is the inertial motion sensors. So not only the study, so that it was used for game. And also the camera is very important, and the GPS is also important. And we can utilize, our researcher in this field can utilize these sensors after the smartphone era. So before that, we need to develop by ourselves. But nowadays we have that. It means that, so we can, it enables us to monitor our behavior for continuously in every area. So I wake up, and first we check the smartphone, and the smartphone knows what time I get up. And also I wear the two wearables every night, and compare the Fitbit and Apple Watch, and they know the sleep state of me. And it's very, very interesting. So I want to use these data for the future support system. And the second big impact is AI. So the 2013, maybe AlphaGo comes to our field. So every people are surprised. The deep learning technologies drastically change our field. So the data, so especially in the image analysis, so the researcher said we don't, so that there's nothing to do, because the deep learning consider the algorithm and achieve the special higher accuracy. So at that moment, 2013, I start considering what happened in the future. I'm still younger researchers, but we need to explore the new research topic in the 10 years later or 20 years later. So the topic is the human behavior change support system. So nowadays, we have the COVID-19, we have SDGs movement. So everyone said human behavior change is important. But 10 years ago, no one said, especially in ICT field, if I say behavior change, every professor says, what is that? So it should be done by company. Oh no, but I want to do that. So this is because I do this research for 10 years now. And then nowadays, human mind changed. No one said human behavior change is not important. So this is because so if I go to the medical hospital, sometimes AI make a decision by checking our X-ray images. So the accuracy exceeds the human recognition. Also, the autonomous drivings come to becomes real. So the AI drive our car instead of me. So we slightly start believe these technologies. And also the life-related make decision becomes so real. So in Europe and the US, AI therapy system have already becomes used. And also in Japan, AI job hunting system or AI HR human resource management system have already started. And if the student goes to the interview, first screening made by AI. So they need to make some answer for AI and AI check the ability of the student. Oh, bit surprised, but the student do that. And also even in the company, for evaluating the employees, they start using the AI, and the AI scoring the employees and calculate the bonus or something. It's slightly started. And the final one is AI matching. This is the matching. So that I make the picture. Actually, many students use the AI matching to find a girlfriend. And my assistant professor got married with the AI recommendation. That is real. So this is because the difference between the 10 years is that we already believe the AI result. So based on the past big data, AI calculate, maybe this result is good for you. And the human believe. I didn't show that, but if we use the Norikai Annai, so transportation support application, 80% user select the first one. So Navi time said, many transportation company try to change the diagram to get the first score at Shinjuku or Shinagawa. So no one considers this is because we can say the people and also the society have already driven by information and ICT. So this is because within these 10 years, slightly, so human mind is changed, so that our technology or our approach is start accepting. And this topic, the human behavior change, is not new, but so in the medical field, it was used for a long time. So used for the treatment for lifestyle disease. So it's, for example, the smoking cessation or diet and salt reduction. So in this field, the medical doctor defined a 5-stage model, and from the contemplation, I cannot pronounce that. So contemplation and preparation and action and the maintenance, these 5 stages is used in the medical field. And the doctor said how to change the stage. That is a behavior change. And traditionally, so the doctor uses the awareness campaign, please do the health check or something, and by using the poster, by using the email, or the consulting by the doctors. That is a traditional way, but we can easily imagine we can use the ICT, a smartphone, in this field. So because the ICT is very, very suitable for this field. So the medical doctor or psychological counselor is a bit far from the ICT field, but actually we should research together with this field, because the ICT has a several good points compared with the existing technologies. For example, we have the push notification. So the many applications actively send the message to us, and that is quite important function of the smartphone. Also, as I said, the human activity recognition is inside these devices. Our step is always counted in the smartphone. And if you wear something, our heart rate is monitored. If we wear something and our sleep is monitored. And also the smartphone is connected to the internet. it can give the rich information to the user. So the compared with some printed one. So also this kind of visualization, so it's good function. And the final one is attractive and fun. So if we use the application, we can easily make some kind of social networks and the social support system. And if we work a lot, so many applications provide a ranking system or rating system. And some application is connected to the point system. And if we work a lot, so we can get some small money. So those kind of system cannot provide by the conventional printed or counseling system. But nowadays, we can use ICT technology in this field. It means the ICT-based behavior change support system. And the most popular ICT-based intervention is the Apple Watch, I think. So as I said, 10 years ago, 2013, I started considering in this topic. And Apple also considered, I think. And the 2015, Apple Watch 2 starts the activity reminder. And if I bought the watch is the device for checking the time. And Apple Watch first, that connected to the smartphone, and that can check the information or type something or sensing our body movement or something. That is the second age. But nowadays, after 2015, Apple Watch makes some command for the human or command for owner. I pay money for the watch, but the watch say, please stand up and keep your health. So it's very funny, but it have already started. And many people convey to the message from the watch. And this is called the digital medicine. So some digital medicine is devices with how can I say, camera, e-table camera or something. But here, the wearable things is called the digital medicine, and actually start using the medical field as a medical medicines. This year is very important year. So the 2015 or 2013, just the imagination, but slightly, so the medical company developed the application. And this year, this September, the first application, Cure Up Hypertension, is start selling in Japan. Now, regularly approved, and the insurance covered this application. If you have the hypertension, 高血圧, and if you go to the medical doctor give you the application. Please download this application as a medicine and pay 2,050 yen, so 2,500 yen per month. Not so expensive, but a bit expensive by as an application. And that is called the summary software as a medical devices. And in our research, so our field, this application now is not only this application, many application is under how can I say, checking. So the medical company invest to this kind of technologies. So this is because it means the ICT can be a medicine for human. That is very interesting. And but not so the community is not so big. So ICT and the psychology, ICT and the medical is a bit far places. So the 2013, Dr. Harry in Oulu University in Finland, I visited to him and talked together about the behavior change support system, because he started the workshop in the partial shift technology at the conference named partial shift technology and called the behavior change support system workshop. And Nishiyama-kun also stay in the Oulu University. This is because I met Nishiyama-kun in this time. And it's very interesting. So in the Finland, the information technology so is for behavior change, it becomes one big laboratory, and they collaborate with the medical hospital or government, and they do a longer research for 2 years, monitoring for the smoking cessation or something. And but in Japan, no community. So this is because I established a small research group in the IPSJ Kansai region and start the workshop every 3 times per year. And now, so this year, so the IPSJ established the behavior transformation by IoT. So the small branch in Tokyo, and it becomes slightly wide and wide. And yes, so this is because if you have an interest, so please join this research group. So in next March, I will organize the IPSJ SIG on behavior transformation by IoT in Kyushu University. So this is because if you have interest, please come to our laboratory. I didn't check time. And until now, I talk about the behavior change support system for the one aspect of behavior support system. So our target, so the previous target of a behavior change is the personal benefit, especially the health. So but nowadays, so the target of behavior change support system becomes wide, spreading. That is a social benefit. It's very, very hard to so deploy a sensor or the deploy application. But for example, the behavior change for SDGs. So many company or university says how to promote the carbon neutral, how to reduce the food loss. So if you have the workshop, or many students, please consider about SDGs, many students like a food loss problem. So that is kind of the behavior change. And also the behavior change for COVID-19. We need to avoid the congestion. We need to wear a mask. We need to stay at home. And also there is some restriction. And these are the public benefit, but the human try to change their own behaviors. So my interest is the second part, how to change the behavior for the social benefit. Very, very big topics. But I tried in Kyushu University now. And the problem is the good ICT is not enough for changing the behavior. As Kawahara Sensei says, contact tracing application is not fully distributed. So there are not so many people installed. Why? And also, I also developed a similar application, but the Mocha or some similar application is not much distributed. Why? Technology is good, but we need to consider. So in Japan, so usually the community, community goes technology first, and please consider how to use that. But nowadays, the researcher should consider how to make accept from the people who uses these kind of application. If we cannot change the society. So, and we start learning about the different field. The famous technique nudge is very important keyword in this talk. So the nudge is the keyword in the behavioral economics. That utilize the cognitive bias. So that we human have some cognitive bias, and they provide the choice, the secondary choice for the human. And that is the definition of the long one. So any aspect of the choice architecture. So if you have interest, please read the original one. And the nudge must be easy and cheap to avoid, and nudge is not mandate. So putting the fruits at eye level is a nudge, but banning junk food does not a nudge. That is a rule. So this is because how to change naturally, unconsciously by using the cognitive bias is nudge. So maybe that is very familiar with the ICT technologies. The example of cognitive nudge, we always affected by such a bias. So the famous one is a loss aversion bias. Is the value loss rather than the more heavy than the rewards. The example is that if you stop showering often, you can save 2,000 yen. That's explain the reward. But the second one, if you keep the shower on, you will lose 2,000 yen. It is emphasize the loss. The second one, so is feel heavier to the student. So this is because if you send some message, we should use the second one if we want to change their behavior actually. So that is used in the marketing system. And also second one is anchoring bias. If you write some, so the original price, the user feel cheaper than if I wrote the direct price. Also the authority biases. So if we ask something from the medical doctor, I believe. But if someone says same things, but someone is not believe, I didn't believe. And another one is a majority thinking bias. That is so big in Asian people. So if everyone does like that, I will do that or something. So we can embed it, such a small bias into the ICT system. And if we can so efficiently control the human behaviors. So interesting is the UCLA have already done such research and published in the Nature. So I bit envy, so that we want to do the similar research like that. They just changed the message in email. So promoting the vaccination in US, so some city provide the airports, provide the baseball game ticket or something. So if they don't provide the reward, the younger people didn't come to taking a vaccine. But the UCLA considered we can use the nudge. And when they send a message, they use the ownership bias into the message and drastically increase the reservation rate and the vaccination rate and published in the Nature. So the very, very small, so maybe from the viewpoint of the ICT researchers, just change the email, not special one, but actually we can publish such a paper to the Nature. So this is because if we collaborate with if ICT researcher work together with such a different department, we can achieve the super research results, I think. And also the promoting the behavior change. And so important is the fun. So there are many research that utilize the game, Pokemon. So that is the paper, the systematic review. So they pick up the many research topic. So based on the Pokemon Go. Of course, the Pokemon Go player just enjoy the game, but they become healthy because they walk. And also they have some additional effect to the city. So it can use for the city promotion. This is because the player unconsciously contribute to the city promotion, but those kind of systems is very interesting. I now work as a technical advisor of the similar game application and insert my idea to the actual game that played in all over the world. So that is very interesting trial. But nowadays I cannot talk about this application, but in future I can introduce the result. And after that, I want to briefly introduce my research topic in my laboratory. So our laboratory do the behavior change support system in several aspects. Mainly the personal benefit, and the big project is a social benefit. And we use the measurement ICT technology for measuring the human behavior. Also, the ICT technology is used for intervention and to the human. We combine the many things, and we have no time to explain the detail of each application, and I briefly add some publication link. So the first one is supporting the user adherence to weight loss application and the behavior change. So weight loss supporting application is widely spread, but what kind of function is important for keep the motivation to the human? we develop the original application and input the several function, ranking function, communication function, supporting function, and the image sharing function, and the which function is important or not. And we do the experiment in the campus and involve the 23 participants and do the 1 month experiment. And finally, so the emotional social support is very, very important. So if the comment from the student, friend is motivate the human to keep the weight loss behaviors. And especially that is very effective for the male. So that is one result. And the result is the number of days per week, challenges done per week is drastically changed by using our applications. We use the smartphone and social support system on the side. And the second one is the eat to pick. We combine, we develop the whole new chopsticks that embedded the sensor and the camera. And it automatically records how to eat and what kind of food are eating. And we record the color and the speed and the timing. And to visualize, so that we don't use the graph, we use the art. And this art is also drawn by my student. And if we eat the healthy food, art becomes beautiful. But if we eat the fried one and rice, art becomes white and brown. So not so good. So that system, so unconsciously recommend the people to use the colorful food. So we develop some tiny, so still developing the more and more small chopsticks. Now current chopsticks becomes wireless and automatically record the color of food I eat and generate the art. And we try to emotionally motivate the human eating behavior. And another one is the aromag, so that we utilize the smell to motivate to reduce the sugar. If we add some we use the embedded the aroma diffuser into the mug cup and make the coffee with less sugar, but the smell, the sweet smell comes, and the people feel that is a sweet coffee. It's very interesting, but we try to develop a new one, and that is one topic to utilize the ICT sensing technique and the actuation technique for reducing the weight and the sugar intake. And another one is the color wall. So just we developed in this summer, and that is the behavior change support for the engineer or researchers. We have the big display, I think. All this member use the big display, and there are the several windows. And when I focus on the email and the coding, but some block is used for Facebook and YouTube, and slightly my attention goes to this content because this is attractive. And we focus on color. If we turn off the color from iPhone, easily can turn on the color, and it becomes a grayscale. And if you start using the iPhone using the grayscale, we cannot. We didn't have an interest on the notification, so that we install make the similar application to the laptop, and we can assign the special application to reduce the color. And if we do move to the cursor to this application, the window becomes monochrome, and the monochrome window dismiss our interest. So that is a video. Left side is a coding. Maybe the right upper side, the setting parameter, we check the URL and the application that can be used in the working time. And if we go to the YouTube, the background application automatically recognize and change the color. and diminishing the interest for the YouTube. And I don't want to watch the monochrome YouTube. This is prompt me, prompt me to back to the coding. So the last week, so we presented this application to the conference, and the one company so eager to use this application for engineers. Maybe after next week, so that application have already completely developed, and we will start developing the company and start the evaluation in the actual engineering environment. So especially nowadays, remote working is widely distributed. We don't want to, so how can I say, keep monitoring the employees, but I want to recommend to use this one so that you can concentrate on the topics or something. Hi, this is kind of the ICT technology for behavior change in the working place. And the second one is this is the trial for the social benefit. So after COVID-19, so our group is around 16 people exist. The 10 faculty members, the 50 students, but then we utilize the Slack, but then not so many people come to the laboratories, and the laboratory is very, so how can I say, so feel alone. So this is because we add the sensor system like a Mocha. So in our case, we developed the beacon to the student. So the very small like air tags that all the students have, and the scanner is deployed on each loops, and the scanner sense the people movement, they automatically uploaded the data, and those information is appeared to the Slack. And our faculty also, all the students, we can easily check who are in the laboratory. And that is just a visualization sensing part. But in my laboratory, so intervention part is the new one, I think. So the AI chatbot, so several kinds of AI chatbot is installed, so that we developed. And if the AI chatbot sometimes asks the mental health to the human or the physical health. If someone, so that I can respond to this one, 3P button. So many people start pushing the 3P, and the AI chatbot recommend to make a coffee. And the coffee bot start voting. So the people who want to drink a coffee, please put a button. And many people put a button. And the number of cups we can recognize. And the AI bot says, please make a coffee among the people in the voting people. Oh, and suddenly I know, oh, I need to make a coffee and serve to the other friend who want to drink a coffee. And the AI coordinate the human communication in the laboratory. Also, the second one, the lunch event, it doesn't work well, but AI chatbot recognize the human existence, the AI chatbot. Let's go to lunch together with randomly selected 2 persons. And sometimes secretary is selected, and the student don't want to go to the secretary. It becomes shame. But I try to still working in the laboratory, and try to involve the people who are not so engaged into the communities, because the number of the group members is very big, especially the international student cannot communicate in Japanese, and they cannot recognize what happened on the Slack. But nowadays we add some additional bot that can support the language. If the international student wrote their own language, automatically translated to Japanese or English. And if the Japanese post something, automatically support the English system. And by promoting such as the communication, we want to stimulate the group itself. And the final one is the supporting the congestion avoidance in the campus. So that is a similar trial with the Mocha, but not only the sensing, our target is intervention, how to motivate the student to change their behaviors. The monitoring system is almost similar. We deploy the scanner and scan the BLE signal of the exposure notification. So that is sent from the COCOA application. Nowadays, COCOA application have already discontinued, and many people are so they uninstall. So this is because it doesn't work now. But 2 years ago, I developed this system and deploy into the campus. And one company come to the campus and have interest, and they provide some small incentive for us. And we provide the small reward to the student and monitor how much reward can change student behaviors. And the changed behavior is that change the place of the lunch, change the time of lunch, or change the style of lunch. For example, taking out the bento or something. And we do this experiment for a long time. And we predict the demand of the campus based by using the 2 sensors, not only the small sensor, but also we use the statistical sensor of the NTT Docomo. And based on this congestion data, we predict the people congestion in the noon and start distributing the reward around the 10 or 11 o'clock before the lunch. And the second one is the cognitive bias in the push message. We use the 2 cognitive bias, default nudge and the loss observation bias. And that is a similar approach of the UCLA research. And time is in time. Okay. And we measure the congestion by the 2 ways. The one is the macro level congestion, 15 grid square around the store. So we can observe the number of people by using the mobile spatial statistics, mobile Kukan Toke by Docomo. So because the campus itself is a bit far from the station. So this is because we cannot recognize how many students come to the campus 5 kilometers away from the station. This is because we monitor the number of stations and also the number of people in the campus in the morning and try to estimate the people in the noon. And the second one is a micro level congestion, because in the campus, several cafeterias exist closely. So this is because we put the small Raspberry Pi in each cafeteria and monitor the human congestion. And as Kawahara Sensei said, not 100 people install the COCOA application. This is because that is the estimated value. So 1 week, I and my student keep sitting in the cafeteria and the bird watch and the actual number of people, and calculate the relationship between the observed BLE signal and actual number, and then roughly estimate the congestion level. And we divide it into the 4 levels of the congestion. And based on this congestion, we calculate the reward to provide. And we experiment the original application that include everything. So that has the push message system, and they can have the check-in to claim that I actually change the time of the lunch, I actually change the place of lunch or something. And and also the point reward come through the application. And the point is not the virtual one, actual money. And the NTT Docomo provide us a big D point, and we can do such a research in the campus. And the experiment time is 6 months. We keep providing the reward to the student, and the student enjoy to get the point. And we unconsciously insert the nudge to the message and compare the activity of the student. And I hired the 1,650 students. It's very tough. We go to no one come to the campus. If I send a message, not so many students attended. So I make the poster and go to the apartment and make the posting, and finally get 160 this kind of the student. And currently the second experiment is going, and we have more than 2,500 student monitors. They have already installed our applications. And the result is like that. So if we use a dynamic reward system, conversion rate is more than 10% increase. And also the cost for acquisition is 5% less. It means the compared to the static reward, so maybe reward is changed, then the student always check and keep the interest for our topics. And sometimes reward is very small, 5 point, and the student contact me. So the 5 point is maybe missing or a mistake or something. And today is a 5 point. And sometimes we provide at maximum 300 point. So for the lunch, additional 300 yen is very, very attractive for the student. And the student always check today's reward and make decision for change or not. So this is because compared to the static one, the dynamic one is very important. And the second effect is the nudge. So as we assumed, so both nudge works well. And but the loss observation bias is much effective for the student. So for example, we can say the limit, gente senchaku, how can I say, first 100 people can get rewards. Only 10 people get a reward. Such kind of loss observation bias works well. And more detailed result is appeared in IEEE Big Data held in Osaka next week, I think. So that is a very, very tough research topic. So more than 10 researchers from the company, and we involved many students and develop application, but we finally get the good result based on that. And this is final one. So I now established a new research group in the Kyushu University, because the Kyushu University is one of the biggest university in Western area. So I involved the researcher in different field and start the empirical research in Ito campus. Fortunately, I already succeeded to involve more than 2,000 students as a monitor, and we do the many research topic, and we want to install our ICT technology to the different field. Thank you very much for attending my talk.
Thank you for very exciting presentation. So, any question for that? Yes, please.
Thank you very much. Very interesting. I'm kind of uneasy if I was forced to change my behavior for social benefit. And I have a lot of behavior I want to change by myself. And I think you are accumulating the common knowledge among for changing behavior. Is there any chance to come up with some platform to change personal behavior?
Of course. So there's some cognitive bias I introduced, but that depends on the human. So someone is affected by the loss observation bias, but someone not affected by loss observation. So as we know the trick of bias, this is because we are not affected by such a bias. So this is because based on the human, so how can I say, characteristics, we need to choose the bias. So maybe the summary software as a medical devices, maybe slightly, especially in the therapy system. So they first check the big five or something, the human characters, and change the algorithm for making the response. Maybe so that this technology becomes more personalized one.
Good, thank you.
Thank you. So the last question, please.
So it's very interesting, and as for congestion avoidance mechanism, then it also can reduce the flatten the congestion of network, wireless network resources or power consumption. So is there possible to joint optimization of such a not only a physical congestion, but network resources or transportation resources or electronic resources to optimize. So such a joint optimization is possible.
Yes, so we got the idea from such a traditional field, I think, but now we utilize the human behaviors. So this is because
by changing a human behavior, such a traditional social resource are also optimized because it flattens the
for the traffic congestion, especially in the city. So all the car navigation system makes the same response to currently same response, but from the viewpoint of the flattening the congestion, the car navigation system should recommend a different route for the user in the same place. And how to get accept from the user is very important. So this is because when we do that, we need to carefully consider the message. If you do this road, it takes 5 minutes more, but good, efficient for CO2 or something. If we say so that the driver accept the different route, more longer route, but we should show some benefit to the user. So that is some psychological aspect.
That's related to the Nakata-sensei's concern, I think. Thank you so much.
Thank you very much. So it's a time to end. So again, thank you so much for your interesting presentation and good conversation. So thank you.